So guys, there was a little delay today in my recording, but it shouldn't affect anything. A couple of things, guys. Our next exam is on July 3rd. We're gonna go over 3.2 today. I'll wrap up 3.2, and your exam will be on July 3rd. I am working on the study guide. Actually, the study guide is ready. These are the sections that I will cover, mostly chapter 5 and the first two sections from chapter 3. Now, you really want to make sure you do the work. I will not record a video tomorrow. I know we have a class, but I'll let you do the homework. The homework problems are ready. If you go to assignment manager, you'll see a lot more here because I'm showing it to you from my perspective, but let's see it from your perspective, if you don't mind. So if you go to students link and you go to MyLab eText, I don't need that actually. You want to go to my assignment, statistics homework, or assignment would work the same. So you'll see 3.1, 3.2. This is all of this is going to be covered on your exam 2. Exam 2 is cumulative. I know it's a little bit of work, and that's why I'm not recording a lecture tomorrow. Okay, so you want to study all these sections. So today we're going to be talking about dispersion 3.2. Let's dig into it. So So guys, in 3.1, we talked about central tendency. We studied mean, median, and mode. They are kind of what's the middle of the data. You have a lot of data points, but what's the average? Central tendency is more about average. Now we are going to study how spread the data is. So the very easy way to measure spread is called the range. To find the range of the data set, you take the highest number and the lowest number and you subtract them. It's really that simple. Let's say these are the scores out of 10. Okay, I have a bunch of students. Let's make it, actually, let's make it 10. And let's make this 5. Now, these are the scores 3, 4, 5, 6, 7, 8. These are the scores 8 students made in a small class out of 10. Okay. Now I have to rank order it. Now, it's always nice to rank order your data, but you really don't need everything. 3. I'm going to put 10 here. Give me 1 second, guys. It's too bright. My screen is too bright. But anyway, 3, 5, 5, 6. 5, 5, 6. I want to make sure I have everything. 3, 10, 5, 5, 6. 3, I've taken care of 3. So this 3 has to go. 10, 10, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So now I have ranked the data. To find the range, I'm just going to subtract 3 from 10. Done. It's really that simple. Now the question is, this is not the only way we measure dispersion. Dispersion is about measuring how spread the data set is. This is one way, the very simplest way, and it's very kind of like the median. It doesn't depend on all the numbers. It depends on, the n numbers. So there is another way, a little more complicated. It's called variance. And we're going to learn how to measure dispersion by measuring variance. Okay, so dispersion, we're going to study two types of dispersions. One is range, the other one is variance. And variance and standard deviation are really the same thing. They are, you just find the square root of the variance and you get the standard deviation. So let's see what I mean. So, well, first let's talk about variance. What's variance? Now, this formula will surprise you a little bit. Okay, it seems like a lot. Okay, variance is a good, it changes when any of the data points change, so it's not resistant. It is affected by any data point. So what you do is, suppose your data points, this is called the population variance. Population means the entire group you're talking about, the whole class, okay? So you take x1 as the first value, subtract it from the population mean, x2, subtract the population mean from it, and the last one, subtract the population mean from it. And we're going to square them because some of them will be positive, some of them will be negative. We will square them. Then we'll divide it by the number of items we have here. It's n. And then we are going to find the square root of it. And that's going to be the variance. Okay. Actually, this is called the standard deviation is going to be when you find the square root. And variance is going to be when you don't find the square root. Don't worry, we're going to focus mostly on standard deviation. And I will give you an example, simple example, okay? Another thing, I'm going to use Excel. I won't teach you how to Excel, but I will do my calculations on Excel and you will be able to see it, hopefully. And let's take a simple case, very simple, okay? Again, I'm not going to teach you how to do Excel, okay? Let me see if I can adjust. It's too bright. My screen is too bright, so I'm going to see if I can adjust it. Excuse me, guys, okay? I think that's a little better. Okay. So guys, getting back, let's say my data set, the entire population is this. So I'm going to do it very slowly. Okay. And there are two formulas. So let's keep the data set here. 4, 5, 6, 7, 7, 9, 9, 9, 9, and what should I get? Let's say 2. Okay. Now, this is my entire data set. Let's say I gave a quiz to 10 students in a small class. This is my population. There are 10 items. First, I need to find the mean. Remember, last class we talked about the symbol mu. It's the mean, okay, population mean. How do we find it? Well, one way to do it is I'm going to go to Excel. I'm going to find it here. Oh, let's find it here. The population mean. And I'm going to do it here. It's somewhere here. Let's find it. Formulas, math and trig. And there should be a mean somewhere. Average arithmetic mean, I think. Okay. Just to let you know, I'm on a new computer, but that's okay. So what I'm going to do, guys, fine. If I can find, oh, I see, it's under statistics. So you have to kind of bear with me a little bit. Okay. More functions, statistical. So average, arithmetic mean. Okay. A through, A1 through. This. Okay. Now, let me make it a little bigger. So you have to bear with me today a little bit. This computer is new to me. Okay. So I found the population mean. But all I did is I added all these numbers, okay, and divided it by 10. So I found the average here, okay? That's one way you can do it, or I'll show you just to make sure I didn't mess up. So I'm gonna just find some. I'm gonna do it two ways just to make sure. Some, and then if you divide 67 by 10, you're gonna get 6.5. So we're good there. Okay, so set it aside. Remember, guys, in the next column, I am gonna subtract mu from everything. Okay, and then I'm gonna square it. So how I'm gonna enter this 6.7 here. You can do it this way. You can just put equal sign and hit this number. It's gonna put it there. Then you can say equal to 6.7. And it's all gonna be 6.7. Again, you can do it another way. I don't care. I'm gonna insert a number here. I'm gonna say this is the mean. And you can use your calculator. Okay, this is my original data. Okay, now in this column, I'm gonna subtract. I'm gonna put an equal sign. I'm gonna subtract and square. Okay, this minus this, and then I'm gonna square it. Caret 2. Okay, now look at this. This is plus. Sure, everything will be plus. Okay, so in the third column, I subtract the mean from everything, I square it. Then I'm gonna go back. Then what do we need to do, guys? Then I will add them all up. I will find the sum of the squares of the differences. Okay, how do we do that? Now that's very easy. You go here and you say type in is equal to sum. You can find sum, and you can go here actually. You can find math and you can do sum. Sum means you're adding everything up. Again, you can do it by hand. If you don't like my Excel and you feel like, why is he doing Excel? Well, don't use Excel. I will use it. That's my sum, right? I'm going to write sum here. Sum of the squares. Now I'm supposed to divide it by 10. All right. And I'm going to write here equal sign. I'm going to go here equal to this number divided by this 10. I'm getting this, right? This is called the variance. If I take the square root of that, I will get the standard deviation. So standard deviation, I'm going to write SD equal to this previous number, the one I got. You can say to the power half is the square root, or if you don't like it, you forget, you can go square root under math and trig. SQRT of this number. 2.3 is the standard deviation. Okay. Now, the good thing about Excel, guys, if you have it, if you save it nicely, I am going to save it. I'm going to do a couple of problems and hopefully we'll check our answers. Okay. So you can just change a couple of numbers. You don't have to. So for instance, if you replace this with 7, look at the population mean will change. I don't want to change it. So to me, Excel is a good way to do some of these calculation. You can, of course, use your calculator. I don't see a problem. Okay. Now, the good news is we are going to do it a second way because there is a second formula and some people like the second formula better. And if we get the same answer, then good news, we didn't mess it up, okay? So once again, how do we do this? This ugly formula simply tells you from first find the population mean, then subtract the population mean from each number, square the answers, add it all up, divide it by n, then take the square root. Now, there is a second formula here, okay? This formula, there is a second formula here. And I'm going to take this, I'm going to see if I can post it here. I'm going to do it a second way. Now, mathematically, the way we did it is same as this, exactly same. Now, what is this? So let me go over, explain this to you a little bit. This one, xi square, means you square each data point and then add it. And this one, it is different. They are not the same. Let me explain this to you here. Hopefully you'll understand. Okay, what we are saying is that this formula and this formula, both are parallel. Mathematically, you can show. Why do people care? Why do people like this formula? Well, this formula is actually easier to calculate. Another thing that this is not same as this, and you really want to get it. Okay, this one is 1 square plus 2 square plus 3 square, more like that. And this one is 1 plus 2 plus 3, and then the whole thing squared. So you have to keep it straight. So we're going to use the same data set to calculate the standard deviation. They're using S for standard deviation. There's actually, well, I have to explain one more thing to you guys. This is going to be, okay, when you use small s, it's called sample standard deviation, all right? When you use this symbol, it's called sigma. It's called population standard deviation. We're actually using population standard deviation. So we have to adjust this formula just a little bit. So let me grab it from your book, the other formula that we're going to use in a second. So we are opening our book to grab the right formula, okay? I grabbed the formula for, it's not very different, but we'll discuss it. Okay, this is the one we're looking for, okay, guys? This is the one we're looking for. Okay. And let me grab one more formula while we are at it. And there are some nice examples, okay? Do take a look at the examples in the book. I'm making up my own examples on purpose. That way you'll have a couple of things to look at. All right. I think we're good. So I'm gonna, guys, so what I'm gonna do, I am gonna use this formula. Now, this formula gives the same thing as the one we just calculated. I'm gonna keep my fingers crossed and I'm gonna get the same answer. And I know it looks a little ugly. So first we need to square everything, okay? So I'm gonna take the same data point, and glue it here, okay? Now, to find this xi squared, I have to square everything. I'm going to write square. I'm squaring everything, okay? How do you do that? Equal sign, 4 square. You can use your calculator if you have the time, okay? No problem. All right, I did that. Then I am going to find the sum here. How do we find the sum? I'm going to, okay, let's write the sum here, okay? So the sum of the squares, okay? And this is the sum of the original numbers. How do we do that? Now you can go and grab sum. I know it's going to say sum. That's the sum. Okay, and you can just drag it. It's going to give you the sum for the next column. Okay, I found the two sums. Now here, I am going to divide this minus this divided by 10. Remember, n is 10, so I'm going to do it here. I'm going to do it very carefully. Okay, this number minus 503 divided by 10. Where's 10? Because there are 10 data points. Now, this is what I got here for the top. Then I'm going to divide it again by 10. This n, capital N is the size of your population. So here I'm going to take this. Well, let's do it. Divided by, let me show you so that you can kind of see what's going on. Here I'm going to put an equal sign. Here I'm going to do this number. Now, if you really are not good with Excel, you don't have to do it. Okay. Let me double check what I did. Okay, so I made a silly error. Let's fix that. So this is going to be this number minus the sum of the squares minus this. And that divided by 10. I'm getting this. Okay. This divided by this. And then we are going to find the square root of 50. Okay. So let me double check what I did. The sum of the squares, okay, these are the squares and I added them, sure. And these are the, all right, so I have to square this, right? I know it's a little messy. Well, let me show it to you. Let me show you one more step, guys, okay? That's why it's a little bit of a problem. All right, let me delete this. All right, so guys, this 67 is just summation of xi. That means I added all the numbers. I have to square it, then I have to divide it by n. Let's do it here separately. So I'm going to square it. I'm going to square it. Okay, that's what I got. Then I'm going to divide it by 10. 10 is the number of data points. And that turns out to be 1. It's not a bad idea to show some of your work. This divided by this 10. 448. All right. Now, what is this? Let's highlight these two. These two are crucial. All right. These two are crucial. All right. So this number 503 is sum of the squares, is this guy right here. Okay. And this 448.9 is this whole mess. So I'm going to subtract them. So how do we do that? I can say here, 503 minus I can say here, this is equal to 503 minus this guy. Okay, fine. Then I'm going to divide it by 10. Okay, why 10? This n. So let's do it here. And if you don't do it, show your work, it's totally okay, except for it's easy to make a mistake. So I'm going to take this guy right here. I'm going to take this guy divided by this 10. I got it so far so good. I got this here and this here. All I have to do is take the square root and hopefully I'll get this. It makes me feel good that I know I didn't mess up. Just think about it. It's so tedious to do. You're going to take this You're going to take this, and you can go square root, but you can just raise it to the power of 0.5. You should know that. Square root of a number is that number raised to the power half, and you can use your calculator too. So we got the same answers. That's a good thing. We didn't mess up. So these two formulas are exactly the same. I don't use the second formula very much. Okay, I do it from scratch. I use the first one. First one is the intuitive one. You can stick to it. Some people prefer the second one. They think it's easier. Sure. So we know we didn't mess it up because we got it right. All right. So this standard deviation, right before you take the square root, this is called the variance. Okay, your book doesn't use it very much. This is called the variance. Once you take the square root, it's called the standard deviation. Okay, this is the standard deviation. This is called the standard deviation. Standard deviation and mean are very, very important. We use it to talk a lot about data. So let's see what else we can say. Okay. So guys, when you are using a sample, not the entire population, we divide the we do the final division by n-1 and not n. Okay. So when you do the homework problems, it will tell you it's a population standard deviation or sample standard deviation. If it's sample, you're going to do n-1. If it's population, you're going to do n. Let me go back and show you. Let me go back and show you here. This is the formula for the one with population. Whatever the population size is, that's what you divide it by. And this is the one for the sample. Okay, see the difference? They're really the same. This X bar is the sample mean, okay? It says that on top. You divide it by n-1 finally. When you find the mean, you divide it by the size of the sample. That's how we define sample arithmetic mean. But when you find the standard deviation, you have to be very careful. If it says sample, you have to divide it by n-1. If it says population, you have to divide it by n. So when you do your homework problem, make sure you read it carefully. They're exactly the same. Other than that, they're really the same. All right. Another thing, I prefer this formula most of the time when I'm asked to find the sample standard deviation. I'll do one from your book today so that you can see how it can be done. So I've done one on Excel. It's very tedious, right? But I'll do one more for you guys. Not a problem. But before we go do some problems, let me go over one important concept that you need to know. It's called empirical rules. Empirical rule. Okay, guys. Now, so the data point that we deal with generally shows up as a bell-shaped curve, okay? This rule tells us that I'll do a couple of problems from your homework packet too. So you have to kind of remember it, okay? There is a lot of theory, but we're not going to go over how they calculate, how they measure it. They're saying 68% of the data, if it's a bell-shaped curve that looks like this, 68% of the data is going to be within one standard deviation, okay? And 95% of the data will be within two standard deviations. And 99.7% of the data will be within three standard deviations. So it won't make a whole lot of sense right now, but when we do a problem, I hope it will. All right, guys. So let's see if we can do a couple of problems from your book. Let's see what kind of problems they have. I'm going to just grab one. Well, let me go get something from MATLAB. You know why? Because the answer is here. And I'll keep the answer handy so that you would know I didn't mess up. Okay, so I'm gonna, what I'm really trying to do, guys, I'm trying to get a appropriate problem, and I can't go back and mess with the problems I've already assigned because the computer thinks I'm kind of changing things for you guys, and the computer doesn't like it. But we'll find one. We'll find one right here. Let's see. Okay, find the sample variance and standard deviation. Again, keep that word in mind, sample variance. And they're giving you a small data set. That's fine. Not a problem. I'm going to keep it here and so that I can check my answer. Okay, again, make sure you understand it's sample. When it says sample variance and standard deviation, you have to divide it by n minus n, and n minus 1 here. N is, I know you probably can't see it very well. N is, I'm going to write it down. Let me take it to the next slide, next page. N is 5. So N is 5. I am going to use Excel, and I'm going to use, I think I saved it. File, save. All right, that's totally fine. I'm not going to use this. Let me do it from scratch. Okay, data set. And I'm going to put the mean here. Mean here. And I'm going to enter the data set, the data points, 21, 13 as carefully as possible. 21, 13, 3, 9, 10. 21, 13, 3, 9, 10. Got it? I'm going to check once again. 21, 13, 3, 9, 10. Okay, so I have to find the mean. How do I find the mean? I have to find the arithmetic mean. And where is arithmetic mean? It's somewhere here under statistics. Go to formulas and go to more functions and go to statistics, arithmetic mean. There should be a mean under math. I'm not getting it right. Anyway, I'm going to just go with average. Okay, same thing. Okay, average of these numbers. This is what I'm looking for. Okay, it is a decimal number and it's not fun, right? Now, I am not gonna, well, let me check. Let me check with you if it's, actually, I'll let you check. I'm gonna go with, I think the mean is correct. So I'm gonna put the mean here. I'm gonna make a column for the whole mean. Okay, let me make it a little bigger for you guys. And let's use time new. All right, that's good. Now, I can drag it, leave it here. I need some room. What do we do in the third column? We subtract the mean from each data point, and then we square it. Caret 2, square. You do the first one. Okay, so I have to enter the mean everywhere, but no, that's much better. So what I did here is a minus b, this is column A, column B, a minus b squared. And that's fine. Now I have to find the sum of this, which is very easy. You can go under math and look for sum. You can just do this. I got the sum. That's not bad. What do I do with the sum? This is population or sample, guys. This is sample. So I have to divide it. I'm going to make it bold. I have to divide it by not 5. 1, 2, 3, 4, 5, but by 4. Okay. And then I have to take the square root. So I'm going to say variance. Variance. you can just write var, that's totally fine, is simply this number, sum divided by 4. The standard deviation is simply, let's just write var. Our standard deviation is basically the variance divided by, the variance to the power half or square root of the variance. Now I'm getting 6.573. I hope that's correct. Let's go check. Let's find out. If I messed up, I have to find the mistake. So they're saying 6.6. I'm okay. I'm okay with it. Let's see what they're saying is a sample variance and standard deviation. Okay, so choose the correct answer. Sample is 43.2. I got that right. And standard deviation is 6.3. And you have to choose for S. S is the sample standard deviation, and the sigma is the population one. Got it? So we got this right. And I would really encourage you to use Excel. Most of you know how to use Excel, okay? I can't turn it into a class where I teach you how to use Excel. So use Excel. You'll be able to use it on the exam, and you can save it. You can see your mistakes. Everything is done. You're not doing the tedious work. Now, if you don't have Excel, you can easily do it on a calculator, okay? But it's a lot of work, okay? So be a little careful. These are my answers. I'm going to highlight them. Let me save this. Not that I really need to. So guys, other than that, I don't have a whole lot to, let me do one more problem. My bad. I wanted to do something like this. Remember empirical rule? I want to do something from empirical rule. There we go. Oh boy. Okay. Now let's do something. You have to find the empirical, you have to find the standard deviation. That's fine. You can use your data to find it. No worries. Let's do something. Okay, let's try this problem. I'm just going to do it here, guys. It says, which histogram depicts a higher standard deviation? So here it's 30 and 70. The spread is about 70 and 30. 70 minus 30 is 40. And here the spread is 60 minus 40, 20. So I'm going to go with A. Okay, just a little side thing. Again, variance is standard deviation and variance. They measure how spread the data is. The part A is more spread than part B. I'm looking for that problem. Okay, this is what I was looking for. Now I am going to copy the answers for my own sanity, but just to check how that goes. So this is a problem from your book. I mean, from MATLAB. All right, then what are we being asked to do? Find out in a second. All right, the standardized tests, math scores, have a bell-shaped distribution with a mean of this and a standard deviation of 105. Okay. So what else is going on? They are saying so basically, let me go back and do it. Excuse me, let me go back. So we have to find out what is mu plus sigma, mu minus sigma, mu plus 2 sigma, mu minus 2 sigma, mu plus 3 sigma, mu minus 3 sigma. So the best way to do it, guys, again, use Excel. Okay, so I'm gonna go use Excel, and I'm gonna use a new one. So my mean is coming from the question, and here I'm gonna say standard deviation, SD. And what are they? The question says the mean is 525, standard deviation is 105. 525, standard deviation is 105. Okay, now remember, guys, we just saw the empirical rule is about one standard deviation above and beyond. Okay, remember this little thing? Let's keep this here. All right, so we're gonna find this guy. I'll do it right here. So this guy minus this guy to this guy plus this guy. Sorry, guys. Give me 1 second. Kind of messed up. All right, much better. Here, I'm going to say equal to this guy plus this guy. These are the points. This is not a minus sign. This is 2. This is a range, okay? 420 to 630, okay? It's going to be 68% of the data will be there. Well, what do we mean by 2 standard deviation? Okay, you're going to take this guy, subtract 2 times the standard deviation. You're going to get it here, 2. You're going to go here, and you're going to take the same mean and add 2 times the standard deviation. Okay, in this range, you will get 95% of the data. Okay, what about 99.7, practically 100%? You're going to get it in this range. And we're going to compare our answers, so no need to worry. Minus 3 times the standard deviation goes here and here. You're going to get this plus 3 times the standard deviation. So in this range, you're going to get 99.7%. So we're going to write it here. 99.7% of the data will be in this range. 95% of the data will be in this range if it's bell-shaped, and 68% of the data will be in this range. Now let's go back and compare our answers. Okay, just gonna cut it so that we know we didn't mess up while copy pasting. Okay, that's fine. All right, 420 to 630. We are gonna look at it here pretty much. 420 to 630. Let me see, 525 to 105, 525 to 105, 525 to 105 is the standard deviation. And what percent standard score? 210 to 840, 210 to 840. That's what we got, 99.7. What percent of the standard score is less than 210 to 840? Less than 210 to less than 210 or greater than 840. So they're tricking us just a little bit, guys, okay? So this 0.3 is 210 to 840. If that is 99.7, so if you subtract 99.7 from 100, you're going to get 0.3%. Okay, so let's see which one they're saying here. 735. So they're just tricking us a little bit. So let me do it carefully with your graph, okay? So far what we did is correct. They are saying Yeah, let's bring this guy here. This is the data we got, and you always want to calculate that, okay? Now, take a look. If this is 68%, okay, this part and this part will be 32% together. If they clearly just said this part, it'll be 16%. Okay. Once again, if you're talking about this whole part, that is 95% of the data, 5% is here, plus here, 2.5% is here. So let's see what they're really trying to ask. So the last one, what percent of the standardized data is greater than 735? What percent is greater than 735? All right. So this is what you gathered from your data, okay? These 2 points are 1 standard deviation away from the mean. These 2 points are 2 standard deviations. These 2 are 3. So now they're saying 735 is going to be here. And they're asking what percent of the data is above 735? Well, it's going to be here. I hope that makes sense. This and this together is 5%. So half of that is going to be 2.5%. That's all they're trying to say. Okay, this 2.5%. So we got it right. So again, you have to read between the lines. It's really not that difficult, but yeah, it's a little bit of work. We'll see. I will stop here. If you need help with anything, please let me know. Other than that, I'm not recording a lesson. You're going to study. You're going to take your exam on July the 3rd. All right, guys. See you next week. Hopefully you guys will do well on the exam. The exam will have about 20, 23, 24 questions, about 2 hours. Okay. Take care. Bye-bye.